Hi guys, so today we'll be solving this problem called permutations. Uh, it's a basic backtracking problem. Let's try to solve it. Given an array nums of distinct integer, return all the possible permutations. You can return the answer in any order. So we've been given an array 1, 2, 3. We have to return as many number of permutations up which are possible of those numbers. So 1, 2, 3 has permutation 1, 2, 3, 1, 3, 2, 2, 1, 3, 2, 3, 1, 3, 1, 2, and 3, 2, 1. So around 1, 2, 3, 4, 5, 6. 6 permutations are possible of the number 1, 2, 3. So the constraints which are given to us are nums.length is between 1 and 6. Nums of I is between minus 10 and 10. All the integers of nums are unique. So let's try to solve this problem. As I said, we are going to solve this problem by backtracking. It's a backtracking problem. You can see here. So let's try to solve it by that. We'll create a vector int perm, okay? Because we have to return a vector of vector. That's why I've created. We'll create a function permute where we'll be passing nums, 0, and perm. So I assume that permute is a function which gives us the number of permutation of that nums array. Now we return perm, okay? Because that's what we need for returning. Now I will write the permute function. So void permute vector int nums. I take 0 as an index I and the vector perm as it is. I'm passing it as a reference because we need to use it as a return value in the previous function, in the main function which we have here. Now let's write the condition which will give us the number of permutations. So when we say that a particular array that has been given to us, we get the permutation by swapping adjacent elements. So we can consider the swapping between the elements. We have to do as many swapping as it is possible. So for that, we will create a loop for int j is equal to I, which is the index at which the current permutation function has been called. We'll start from that. J is less than nums.size j plus plus. And in this function, we will be swapping nums of I, comma, nums of j. And we'll also be doing a function called permute where we'll be passing nums and I plus 1, okay, and perm vector. Now let's write a base condition where it will hit the base condition and return. Otherwise, we don't need to have a return value because it's a void function, but still it's better to write the base condition where the perm would end. So if I is equal to num size, at that time we will be returning perm dot push underscore back nums of I. Okay, not nums of I, just nums, because we have a vector of vector. So I is equal to num size, which is if I plus 1, I plus 1 is equal to nums dot size, which is it has reached the last limit of the nums size. At that time, we push back into the nums array. So let's try to run the code to see if everything is working fine. Yeah, that works. All right. So I hope you guys understood the problem. It's a basic backtracking problem, as we are considering every possible solution which is there for us in order to get to the permutations which we want. That's why we are trying to get as many solutions which are possible. We've also made a base condition, that is, if we hit I equal to the num size, at that time we push back into the perm array, perm vector, sorry, and we go from j is equal to I, j is equal to I plus 1, j is equal to I plus 2 till the nums dot size, and we just swap the adjacent elements. So I hope you guys understood the problem. Thank you. Do solve it.